Okay, section 2.3, video, part 5. Hopefully we'll get out of this section after this video. What I want to talk to you about, I'm going to change directions just a little bit. And I want to talk to you about naming a function, giving a function a name. Now, if you'll remember a while ago or in the last video, whenever we were talking about finding the domain of an equation, remember we said we always started out and we solved it for y. So in other words, we maybe wrote something like y equals 3x plus 7, or y equal x squared minus 2x plus 3, something like that. Whenever we give a function a name, whenever we give a function a name, we always put the name in this y spot right here. And so I'll put the name of the function in place of the y. So we'll put the name here. We'll put the name here. Now, whenever we name a function, just a little straighter. Whenever we name a function, we give it a first and a last name. Just like when you're born, you have a first and a last name. And so when we name a function, well, first, the purpose in naming a function. The reason we give a function a name is, you will see this in the next section. Sometimes when we're dealing with algebraic problems, there are some instances where you're dealing with a problem that has multiple functions in it. So the purpose in naming the function is to distinguish the difference between the two. And I know you get this, but it's like if I walk into a room, and I'm sorry, I'm just trying to get this straight, so I will get it straight in just a second. When I walk into a room and there's multiple people in here, the way I call out one is I call them by name. So that's the purpose sometimes in giving a function a name. Now, back up. How do I know that both of these are functions? Let me say that first. How do I know this is a function? How do I know this is a function? You remember 2 videos back, it's a function if your power of y, if your highest power of y is not even, the highest power of y here is to the first, and y can't be in absolute values. So both of these are functions based on the definition of a function. Now when I go to name it, we give a function a name. We give it a first name and we give it a last name. We give it a first name and we give it a last name. We always put the last name in parentheses. It's just how we do it. Now, just like when you're born, your last name is fixed. Well, when you name a function, its last name is fixed. The last name of the function always goes in the parentheses, and the last name, we use letters of the alphabet. And the letter that you use will always be the letter that's over here. So right here you see the X, so this would be X right here. Over here, what letter do you see? X, so it'll be an X there. Now, if these were eons, this would be an eon. If this was T's, this would be a T. So the letters that's on the right side of the equal sign is always the letter that goes in the parentheses. So you say, so can 2 functions have the same last name? Yes. Can't 2 people have the same last name? Certainly. So these 2 functions here have the same last name because they're both X's. Now, the first letter, the first name, could be any other letter of the alphabet you want to use. So for right here, I could put A, B, C, D, E, F, G. It doesn't matter what letter I put. Same thing over here. Now, since these 2 functions are different equations, I wouldn't want to use the same letter for this one as I do this one. 2 common ones that we use a lot is F and G. Now, I can't exactly tell you why, but that's just the way we do it. So the letter F here doesn't stand for function. And when you read this, you don't read it F times X. We put the word of in the middle. And we do that so you won't use the word times. So when I read this, this is F of X, and this is G of X. So the name of this function is G. The name of this function is F. Now, here's the reason we like to do that. If I ask you to find F of 5, remember we talked in the last video about the number you put in is your input, your X. The answer you get out is your Y value. If I want to find F of 5, what that simply means is it means take 5 and put it in X's place, but this is the function you're using. So if you do F of 5, you just put the 5 right there. Now, we're going to do that in our head for right now. So what's 3 times 5 is 15, and 15 plus 7 is 22. This is the exact same thing as that. I know that it looks different, but it's the exact same thing. Now, if I said find G of 5, that would mean go to the G function, which is this one over here, and you put this in X's place. So I'd come right here and put a 5 here and a 5 here. So 5 squared is 25. 2 times 5 is 10. So 25 minus 10 is 15. And 15 plus 3 is 18. So when we read this, we would say G of 5 equals 18. This is your X. The answer you get out is your Y. So this is the same thing as 5, 18. It's the exact same thing. There's no different. And so it just looks different. So that's the purpose in giving a function a name. So whatever's in this parentheses goes in X's place. So if I said, what is G of T? What would I do? I would replace the X up here with T's. So that would be T squared minus 2T plus 3. So this goes in your X's place right there, whatever that is. All right. So write these instructions down. We'll look at a couple of examples together. Here's the instructions. Use the following functions to answer the questions. All right, so here's what I'm about to do. I'm about to give you 2 functions. Now, these 2 functions may change from one problem to the next. So here are the 2 functions. All right, now, here's what I'm about to do. I'm about to just, I'll show you going through this time. All right, so here's what I want to do. This is the question. Find the following. Find G of negative 3. G, make sure you can see that. Yeah, you can. Find G of negative 3. All right, this means 2 things. And remember, this is the whole thing is the same thing as Y. All right, so what we're doing, we're putting negative 3 in X's place. This is the function you're using. Now, is that this function? No, that's F. We're using the G function, so you're going to put the negative 3 right there and right there. And then when I do that, just do the math. So pause the video and copy this. Okay, so you got negative 3 squared is 9. Then negative 2 times negative 3 is plus 6, and then work that out. So this is your X, and this right here is your Y. Now you don't have to write that as an ordered pair. I'm saying that for reasons I'll show you in just a minute. Okay, so let's do this. F of 0. All right, what does this mean? This means you're using the F function and you're putting 0 in x's place right there. So when you do, it's 3 times 0 minus 1, which is negative 1. Now, same thing if I said find F of m. Same thing, you're just plugging m in. Plugging m into x's place in that function right there. You just can't do anything with that. Okay? Now this next one, I'll show it to you and let you copy it. So let me slide it up. Let me make sure you can see it before I say it. Okay, pause the video now and copy this one. Okay, so you should have this one copied now. All right, so here's what we're going to do. Find g of this. So here's what we're going to do. We're going to take every bit of this, x minus 3, and we're going to come to the g function, which is this. And we're going to replace x with x minus 3. So I'm going to put an x minus 3 here and an x minus 3 here. So it's going to be 3 times x minus 3 squared minus 2 times another x minus 3 plus 1. So put an x minus 3 in both of those places. Whatever's in parentheses goes in x's place. So it's 3 times x minus 3 squared minus 2 times x minus 3 again plus 1. Now, orders of operations, you square first. How do you square x minus 3? Remember to do that. You don't just square the first one, square the last one. Go to the side and write x minus 3, write it out twice, and use the FOIL method. And when you do the FOIL method on this is what you get. So you get a middle term. So when you square this properly, you get that. Then distribute and combine your like terms. Now, you're not doing anything with this. You don't set this equal to 0 and try to factor it and all that. Once you simplify it, that is your answer. You're not solving it for x. Okay? Now, let's write this next group of problems now. Next set of instructions. Here's the problem. Here's the instructions. Use the following functions to answer the following questions. Now, you say, well, wait a minute, that's exactly what we just did. It is. Same instructions. But the functions I'm going to give you now are a little different. And by the way, let me go back and say this first. You can't answer these questions if I don't give you these two functions. I have to give you the two functions in order for you to answer the questions. And the functions change from one problem to the next. All right, so here's what I'm about to do. I'm about to give you two functions. So suppose here's what they are. Pause the video and copy this. Okay, you should have this copied. Now, what's the difference in this one and the one I just worked? The difference in this one is I didn't actually give you the equation of the function. In other words, the thing that has the x's with it. But these are still functions. How do I know these are functions? A function, none of the x's repeat. That's a function. A function, none of the x's repeat. That's a function. Okay? Now, let's find f of negative 8. Now, let me cover this up. We're going to do a bunch of others these, but let me write it. So I want to find f of negative 8 equals blank. Now, how did we do this just a second ago? You took negative 8 and you plugged it in x's place and you found y. Well, this is a little different because we're not given the equation. So in order to work this, you have to understand what this is asking. Remember what I said a while ago? This number right here goes in what place? In x's place. the answer you get out is your what? Your y. So here's all this is looking for. This is saying this. Go to your F function, which is this one up here, and find the ordered pair that has an x of -8. Find the ordered pair that has an x of -8. There it is. And give me the y that is paired with that x. So the y that is paired with that x is 6. Now you say, Mr. Reiner, I have a question. What if there had been two of them up here that had a -8 for x? That's not possible. Remember, if that happens, it's not a function. Okay? So, let's do some more of these. All right, so how would I do f of 0? Go to the f function, find an ordered pair that has a first number 0. There it is right there. And the y value is paired with is 7. G of 8, go to the g function, find the first number 8, right there, and the y value is paired with is 6. Go back to G again, find the first number 4. There it is right there, it's paired with -11. Go to f of 4, go to the f function, find the first number 4. There it is, and it's 2. So see, G of 4 and F of 4 are two different things because you're using two different functions. Now let's do G of 6. Go to the G function, find the one that has a first number of 6. None of them. So G of 6 does not exist. All right, now, let's look at this one. Make sure you can see that at the bottom. Yes, you can. Okay, right here. It says f of x equal 2. So we're not looking for this number over here now. We're looking for the x. So we're looking for this. So now what you're doing is you're looking for the first number. You know the second number. This is your y right there. So go to the f function, which is all the way up at the top, and find an ordered pair where the second number. Come to the f function and find an ordered pair where the second number is 2. Right there. And the x that's paired with that is 4. Okay, last example here to close out this section. So write these instructions down. Use the following graph to answer the following questions. All right, let me show you the graph first. Now, let me show you something about this graph before you copy it. So hold up, give me just a second. Now, this graph, remember a couple of things. First, this graph has points all over it. So there's points all along here. But I bubbled some a little bigger where you could see them. So make sure this is the point 1, 2. This is 2, 3. This is 3, 3. So that's straight across. And then it drops to that point. Then it drops to 5, -1. And then it turns and goes back up. Has an arrow on both ends. So pause the video now and copy this graph. Okay, you should have this graph copied. Now, let's answer these 3 questions. F of 4. Well, how do we usually find f of 4? Plug 4 in for x, but I don't have the equation. Well, look at ordered pairs. I don't have ordered pairs, but I have a graph. Here's what we're looking for. We're looking for a point on the graph that has a first number 4. So come over to where x is 4, that point right there, and this is the point 4 comma what? 0. Okay, now let's do f of 1. Find a point on the graph, 1 comma something, but it's got to be on the graph. So this is 1. That point right there is 1 comma something, and that something is 2. So this is 2. And then f of 5 would be find a point on the graph where x is 5, that point right there, and give the y that is paired with, which is negative 1. Okay, the last thing I want to do, and it'll close out this section, and this video and this section, is this. You'll have 1 or 2 problems in your homework where it says, where is the function increasing, where is it decreasing, and where is it constant? Now, it's real easy to talk about. Remember, your function is when you solve it for y. So whenever it says where is the function increasing, that means where is y increasing. Now, if y is increasing, remember your y-axis, that's up and down. So your function is increasing just simply this, when you're going uphill, because your y's are getting bigger and bigger. Your y's are getting smaller and smaller if you're going downhill, and your function is constant where the graph is straight across. So if you're going uphill, you're increasing. Downhill is kind of like riding a roller coaster. Uphill, you're getting higher. Downhill, you're going down. So the y's are getting smaller and constant straight across. Now, whenever you're listing where a function is increasing, decreasing, and constant, you're talking about intervals, the x-axis. So when I say where is it increasing, I don't want to know how high it gets to. I want to know at what day, at what place does it reach that height. Like if I ask you, what was the hottest day of the week last week? And you say 98 degrees. You're not answering my question. I'm not asking the temperature. I want to know the day of the week. The days of the week is like the x-axis. So when I say where is it increasing, I'm talking about your x-axis. All right, so here's what we're going to do. We're going to do this one together. First, how far does this graph go left? To negative infinity. So, slide this up a little bit. All right, let's start tracing this graph. Okay, is this graph increasing or decreasing as I trace it? I'm increasing. So let's write the word increasing first. So we've got increasing, decreasing, and I'm going to put C for constant. All right. Now, I want to know interval-wise where it's going up. All right. How far does this graph go to the left? Negative infinity. Now, trace the graph until you quit going up. Stop. Now, I do not want to know how high you go. I go up to 3. That's not what I want to know. I want to know where I quit going up. That's right here at 2. And increasing, decreasing, and constant, we always use nothing but parentheses. Okay, now, let's go back to where we left off. Now, when I start going now, am I increasing, decreasing, or constant? I'm constant. So you pick up at 2, and you go all the way over here. You're still constant to 3. So you're constant from 2 to 3. Now, keep tracing the graph. Now I'm decreasing. I'm starting at 3. Remember, this is where you look. You don't look this way, you look down. So I'm decreasing, starting at 3. Now let's trace the graph. Going down, 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 stop. Now once again, I don't want to know how low I go. I want to know where I quit going down. I stopped going down at 5. And then when I leave here, I'm increasing again. So come back up here to increasing. You started at 5. And then you increase forever to the right. So that's infinity. So that's how you determine where a graph is increasing, decreasing, or constant. That concludes section 2.3.